Welcome. Today we're going to be talking about linear equations. A linear equation is an equation, which means it has an equal sign, where the highest power of the variable is 1. When we're solving linear equations, you start out with a one-step equation, and then you move into two-step, and then you can move into multi-step. And if you understand the process of using inverse operations, then you can solve very complex linear equations. You will see linear equations in 1 and 2 variables, meaning you could just have the variable x, or you could have y equals x. We're going to focus on variables without a y today, where we're just solving standard equations in terms of x. Inverse operations are operations that undo each other. If I give you $5, I take $5 away, I'm back to where I started. They undo each other. If I doubled something, taking half of that would undo it and get me back to where I started. Multiplication and division, and addition and subtraction are inverse operations. The reason this is relevant is because when you approach a linear equation in terms of solving it, what you're doing is you're trying to figure out, what do I need to do to get x by itself? Your whole goal is to isolate the variable. You're trying to get x alone. And in order to do that, you have to undo whatever's happening to x. If x is being multiplied in the equation, you need to divide to get to a single x. If you're adding something to x, you need to subtract something to get x by itself. So your goal is to isolate the variable and have just a single variable on one side and have the number on the other side. Multiplication looks like a number and a variable next to each other without a multiplication sign. We typically start out using a multiplication sign when we're in elementary school with the x, and then we move to a dot, and then we just move to a coefficient. So a number in front of a variable is actually multiplication. It's implied multiplication. So 2x means 2 times x. Division is typically represented in an equation by a fraction. You'll write a variable over some number, and that is division. We don't use the division symbol typically when we're writing equations. X over 2 is x divided by 2. This is division. If I wanted to get, for the multiplication of 2x, if I wanted to get x by itself, I would need to divide that 2. If I wanted to get the division of x over 2, if I wanted one single x, I would need to multiply by 2 to undo that. Addition looks like x plus a number or a number plus x. In both of these situations, you're adding 3. Notice that there is no plus sign in front of the 3 in the second example because it's positive, it's implied. To undo this, I would subtract 3. For subtraction, you would see x minus a number. You could also see subtraction as a negative sign. So for instance, I could write -7 plus x. It looks like you have addition, but you are adding. You're adding a negative number, and a negative number and subtraction are the same thing. This is actually, if I was to try and get the x by itself here with the subtraction, I would add 7. So it is subtraction, and I'm undoing it by adding 7. So let's approach a one-step equation and see what we do. I personally like to solve equations by drawing a line down the equal sign. I don't do it all the time, but when I very first start out, I draw a line down the equal sign. And then I circle the variable. This helps me identify the two sides. So when you're solving an equation, what you do to one side, you have to do to the other. So this helps me identify the two sides that I'm working with. And then circling the variable helps me know what's happening to it on the side of the equal sign. So right now, on the side with x is not by itself, it's not a single, I have x plus 4. And in order to solve my equation to have x equals, I need to get rid of the plus 4. Plus 4 is undone with -4. Addition is undone with subtraction. So I'm going to subtract 4 from both sides. That's why it's nice to have that line so you can see the two sides that you're talking about. I keep my x. 4 minus 4 on the left is 0, and that's the goal. The goal is for that to go away and move to the other side. I write my equal sign, and then I do 10 minus 4, which is 6. And so x equals 6 would be my solution. How do I know if it's right? I substitute it back into the original equation and I check. 6 plus 4 is 10. I did the right math. It's a great thing about equations. You can always take your answer and plug it back in and make sure that it's true. Moving on to the second example. I'm going to draw a line down my equal sign and circle my variable. So again, I just have a single x, but I have -4 on the side of the equal sign, same side. To undo subtraction, I'm going to use addition. So I'm going to add 4. I don't get to just add it to one side. I have to add it to both. I have to add it to the 10 as well on the other side of that equal sign. I write my variable. -4 plus 4 is 0. 10 plus 4 is 14. When you have your equation, you're keeping things balanced. If you add 4 to one side and you don't do it to the other, then you're not staying equal. You have it tilted. You need to bring up the other side to keep it equal. So you've seen an example of addition and an example of subtraction used to solve equations. What about multiplication and division? Drawing my line for my equal sign, here's my x. And right next to my x is the number 2. That's implied multiplication. The way that I undo multiplication is I do division. I don't write the division sign. I don't write divide by 2 on either side. I use a fraction bar and write 2 underneath it. And what I do to the left, I have to do to the right side of the equation. And the goal of that is 2 divided by 2 is 1. I don't want it to be 0 here because then that makes the variable go away and I'm not solving my equation. 2 divided by 2 is 1 whole. So then I have x left on the left-hand side. This simplifies to 1. And 10 divided by 2 is 5. And check myself again. 2 times 5 is 10. I've done the right math. In the next equation, draw my line, circle my variable. Right now I have x over 2. And that is division. I undo division with multiplication. So I'm going to multiply both sides by 2. I'm going to use a dot for that representation. And again, the goal is for us to have a single x on one side of the equation. 2 divided by 2 is 1. That leaves me with a single x, which was my goal. And 2 times 10 is 20. Checking my answer, 20 divided by 2 is 10. That is true. I did the right math. All 4 of those examples were examples of one-step equations because all I had to do was one thing. Let's move into 2 steps, where we're going to do 2 steps. How do I know what to do first? When you learn how to evaluate and follow the order of operations, you'd follow PEMDAS or GEMDAS or whatever example you want to, where you do parentheses, exponents, multiplication and division together, and addition and subtraction. So you have an order in which you're evaluating. When you are solving equations, you actually reverse the order. You want to add and subtract first, and then multiply or divide to get x by itself. There are some exceptions to this that you'll see, but typically when you have x that's attached to a number and subtraction outside, you add and subtract first and then multiply or divide. So the first thing that I'm going to do then, I have multiplication by 2 and I have subtraction by 8. So I'm going to add 8 first. Add it to the left, add it to the right. And then I drop down the thing that I haven't touched. I haven't touched the 2x. -8 plus 8 is 0. 10 plus 8 is 18. I don't have a single x still. I need to get x by itself. This is multiplication. I undo it with division. I'm going to divide by 2 on both sides. 2 divided by 2 is 1, so I have 1x on the left, and 18 divided by 2 is 9. Notice I didn't write 1x. It's not necessary. The 1 is implied. Double checking my work, now I'm going to follow the order of operations. 2 times 9 is 18. 18 minus 8 is 10. I've done the math correctly. Looking at my next example, here I have multiplication and subtraction, just like previously, except I have parentheses now. And typically I do what's inside the parentheses first, and then I would multiply, but I'm going to reverse that. So I'm actually going to undo the multiplication first, and then I'm going to work inside the parentheses. So that multiplication is undone by dividing by 2. I'm left with x minus 15 on the left-hand side. 10 divided by 2 is 5. Now, some teachers might have taught you need to distribute first. You will get the same answer if you distribute first or if you did the division. It's actually just a little bit shorter to do the division. If you distribute, then you're going to have 3 steps in this problem rather than 2. I'm going to undo the subtraction of 15 by adding 15 to both sides. 5 plus 15 is 20. That's my answer. So doing inside the parentheses first, 20 minus 15 is 5. 5 times 2 is 10. I've done the math correctly. Something else you might encounter here, I have a fraction. A fraction is multiplication by the numerator and division by the denominator. You can break this up into 2 steps, where you undo the multiplication and you undo the division. Or it can use what's called the multiplicative inverse. You can multiply by the reciprocal. So multiplying by the reciprocal means you flip the fraction and you multiply both sides. Why? Think about fraction division. When you divide by a fraction, you actually change that into multiplication of the reciprocal. It's the same thing. So I'm going to multiply by 3 over 2 on both sides. Now, some people would say 3 times 2 is 6, 2 times 3 is 6, and 6 divided by 6 is 1. Or you can reduce before you multiply. I have 2 and 2, one's in the numerator, one's in the denominator. I can divide out 2 by 2. 3 and 3 divides out. 3 divided by 3 is 1, 3 divided by 3 is 1, and so I get 1 whole, which was the entire goal to begin with. That leaves me with x on the left. Now on the right-hand side, some people go, well, it's this fraction, what am I supposed to do? You can put 10 over 1 if it makes you more comfortable. But again, I don't have to do 10 times 3 and then divide by 2. I can reduce first. 2 divided by 2 is 1, and 10 divided by 2 is 5. And then I multiply across. 5 times 3 is 15. 1 times 1 is 1. I don't need to write 15 over 1 because every whole number can be written over 1. Just better practice to not write over 1. Checking my math, 2/3 of 15. I'd simplify, I'll show you that. Just simplifying as before, 2/3 of 15. 3 divided by 3 is 1. 15 divided by 3 is 5. And 2 times 5 is 10, which is what we needed to do in our equation. Let's add now where we have a variable on both sides. When you have a variable on both sides, before you add and subtract, multiply and divide, you actually need to combine your variables so that you know which side of the equation you're dealing with. It does not matter which side you move the variable to. One will cause the variables to be positive in this situation, one will cause the variables to be negative. You will get the same answer in the end if you've done your math correctly. Some people always like to move to the left. Some people like to assess and see which one's going to make it positive. I'm going to go ahead and move the 2x. How do I move the 2x? Do I divide by 2? No. Whenever you are combining x's, when you're trying to get something from one side to the other, and you're worrying about combining these variables, you are doing that with addition and subtraction. I don't want to divide away the 2 or the 4 right now. What I want to do is I want to move the 2 or the 4, so I'm going to add or subtract. So to move 2x is currently being added. I'm going to subtract 2x from both sides. This leaves me with 18 equals 10, negative 4x minus 2x. That's negative 4 minus 2. Same signs, add them and keep the sign. That's a negative 6x. And now my variable is here. I have a 10 on this side. I need to move the 10. How do I move a 10 without separating it from a variable? I move with addition and subtraction. Is the 10 positive or negative? If it was negative, there would be a minus sign in front of it. So it's positive. How do I undo plus 10? I subtract 10. So these are the things I'm thinking as I'm working through the equation. So I'm going to minus 10 from both sides. 18 minus 10 is 8. And I still have minus 6x. It's very important that you drop that sign down. Now I want to separate the negative 6 and the x. So I divide by the negative 6. I don't just divide by 6, otherwise I'd be left with a negative x. So I'm going to divide both pieces by negative 6, both sides of the equal sign by negative 6. That leaves me with a positive x on the right-hand side equals negative 8/6. I am not turning that into a decimal. That's going to be a repeating decimal. I don't like that. I could reduce this. I could make it a mixed number. As you move further into your math, when you get into calculus and you're higher up in your linear equations, it's not really helpful to make a mixed number. So I'm just going to reduce this by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So this is negative 4/3. You could write it as negative 1 1/3. Negative 1.3 with a bar over it. I'm not a fan of that. It's easier to just leave it as a fraction. Let's do another problem. Okay, now I have a fraction on the outside. I have a 10x. I've got an x on the inside, and I don't really want to distribute. The reason that I don't want to distribute is because I'm going to have to multiply 2/5 times a 3. That's not going to really be great. I want to undo that 2/5. How do I do that? Let's say I multiply by the reciprocal. Let's say I multiply by 5/2. That means I need to multiply the entire right-hand side by 5/2. Not just the 10 or the 1. It needs to be the entire side because I'm multiplying what I'm doing to one side, I'm doing to the other. This 2/5 is attached to this entire x minus 3 in parentheses. And so multiplying on the outside is going to clear that up for me. 2's divide out, 5's divide out, and that leaves me with x minus 3 on the left-hand side of the equal sign. But what happens here on the right-hand side? I need to take 5/2 of 10x, and I need to take 5/2 of 1. And this is fraction multiplication. Essentially, you have 10/1 times 5/2x plus 1 times 5/2. 1 times 5/2 is 5/2. But let's simplify. 2 divided by 2 is 1. 10 divided by 2 is 5. 5 times 5 is 25x plus 5/2. I want to combine my variables. So what I'm going to do here is I'm going to subtract 25 from both sides to get the x's on one side. One x minus 25x, those are opposite signs, so I need to subtract and keep the sign of the bigger number. That's going to be a negative 24x. So I have negative 24x minus 3. That leaves me with 5/2 on the right-hand side because 25x minus 25x is 0. It doesn't mean that I've done something wrong because my numbers aren't friendly. Just means that I'm continuing to solve through the equation. Sometimes you'll get to a point where you think you've made a mistake because it's not all clean and pretty. Well, life is not always clean and pretty. Just means that this is a tougher problem or more involved, not tougher, but more involved. I have the x on the left-hand side. I need to move the 3 to the right to get x by itself. So I'm going to add 3 to both sides. That leaves me with negative 24x equals 3 plus 5/2. If I multiply 3/1 times 2/2, that's going to give me 6/2. I don't want to reduce it. The whole point was to have a common denominator. So I have negative 24x equals 6/2 plus 5/2. 6 plus 5 is 11. and I keep the denominator. I don't make it 4. Remember, when you're adding and subtracting fractions, you keep the denominator. And now finally, I'm going to divide by negative 24 to get x by itself. I have 11 halves divided by negative 24. This is a fraction divided by a fraction, even though it doesn't look like it. So what I'm going to do is I'm going to multiply by the reciprocal. I'm going to take 11 halves times negative 1 over 24. I cannot simplify anything. I multiply straight across. First of all, a positive times a negative is a negative. 11 times 1 is 11. And 2 times 24 is 48.